So if I have a quadratic equation representing some parabola, and I want to put it into vertex form. Remember, vertex form is x minus the x value of my vertex, quantity squared, plus k, which is the y value of my vertex. To get it into that form, I've got to come up with a completed square, we call it, or a perfect square that is a trinomial. It's going to be a trinomial, but we're going to be able to write it as a binomial squared. Well, first let's look at what that really means. So over here I've got a binomial squared. Obviously, that anything squared is that thing times itself, right? So x plus 3 times x plus 3 in this case. And if I do the distributed method here, distribute the x, distribute the 3, I'm going to get x squared plus 3x plus another 3x plus 9. And these are going to combine to x squared plus 6x plus 9. Now let's notice something here. Notice my b term, because this is standard form, ax squared plus bx plus c. My b term here, my b value, is twice what was inside the parentheses. Twice. My new c term is my constant that's in my parentheses squared. So 3 squared. So if I was at this point, x squared plus, let's say 4x, and I wanted to come up with a new c term, I could complete the square by coming up with x. I take half of my b term, so I'm going back the other way now. Half my b value is 2, and then I square that, and that's what I put in here. 2 squared is 4. I also have to subtract 4. And that keeps the equation balanced if it's an equation or if it's just a function. Okay, I've got a standard form quadratic equation here, and you might recognize this is vertex form. If I'm wanting to change this quadratic equation into vertex form, I have to put it into this kind of format. Well, in order to do that, notice how I have this binomial squared. It could be just x squared, but in this case it's x minus the x value of the vertex squared, all squared, plus the y value of the vertex. Well, here in standard form, I don't have my vertex readily visible. I only have my y-intercept readily visible in standard form, which doesn't really help me in this case. So I need to convert this into vertex form. There's a couple of different ways to do this. One that they normally teach in Algebra 1, Algebra 2, and another that they might not teach, but it also makes sense to most people. Let me do the normal way is to complete the square. I'll do that first. To complete the square, I look at my two values that have x's in them, my two terms that have x's in them. Right now, you can tell that this is not a perfect square, because with a perfect square trinomial, half of my b value squared is my c value. I'll show you what I mean by that. If I have x, let's say x plus 5 quantity squared, that means x plus 5 times itself, x plus 5. Anything squared is that thing times itself. So if I do the distributive method here, distribute the x to both of those terms, distribute the 5 to both of those terms, I get x times x is x squared. X times 5 is 5x. 5 times x is another 5x. and 5 times 5 is 25. So notice my new b value is going to be 10x, which is double what I had in the parentheses, and my new c term here is 25, which was 5 squared. And then here I still have x squared. So this is equal to x squared plus 10x plus 25. In other words, this b value here, whether it's positive or negative, is exactly twice that. Now, if I'm going back the other way, I need to take half of that to know what goes into that parentheses. So now that we've seen that, now I can put this into vertex form. I'm just going to look at these first two terms because half of 4 is 2 and 2 squared is not 5, right? So it's not already a perfect square trinomial, so I can't just put it into the perfect square binomial squared. Therefore, I have to just look at these two and I say, okay, well, I'm going to come up with a new c value. I'm going to shove this 5 out to the side. I'm going to come up with a new c value so that this is a perfect square. So as we've seen, I can write it as x plus or minus something quantity squared, right? Well, in order to know what goes in here, remember, it's half of my b value, which in this case is 2 now. And then I have to know what my new c term is here. It's 2 squared, which is 4. Now, if this is an equation, we don't want to change anything about the other side. We just want to change the form of this side. So if I add 4 here to make this into a perfect square trinomial, I also have to subtract 4 to keep the equation balanced, because I'm not adding 4 to both sides or anything. I'm adding 4, so I have to subtract 4. And then when I combine these constants, plus 5 and negative 4, I get a positive 1. And now I'm done. I'm in vertex form. My vertex form of this quadratic is x plus 2 quantity squared plus 1, where my vertex is negative 2, because the opposite of that, and positive 1. So my vertex is negative 2, comma 1. Now let's look at the other way. Remember that a quadratic represents a parabola on a graph. And the parabola has a line that goes right down the middle, vertical line, called an axis of symmetry, or line of symmetry. Now the equation for that axis of symmetry is x equals negative b over 2a, where we're talking about your quadratic equation in general form being ax squared plus bx plus c. You take the b value here and the a value, and you put that into this little formula here, negative b over 2a, and that's the equation of that axis of symmetry. Well, now notice also, obviously, since your axis of symmetry goes straight through the middle of the parabola, your x value of your vertex, h comma k right here, your x value of your vertex has to be the same as the x value of your axis of symmetry. So when we have a function in standard form, we can just find the x value of the vertex. We can just find the x value of the vertex and use that to get the y value of the vertex, and then put it into vertex form. We can just pop it into vertex form at that point. Remember, vertex form is y equals, I'm going to put an a here because the a value is the same as there, x minus h squared plus k, where h and k are the x and y values of the vertex. So in this case, the one we just looked at by completing the square, if I take negative b over 2a, negative b would be negative 4. 2a, well, a here is just 1, so 2a is just 2. Negative 4 over 2 is negative 2. that is the x value of my vertex. So now that I have the x value of my vertex, I can just put that into my standard form of the quadratic, and the y value is going to be the y value of my vertex. So if I put -2, I got to be careful because it's negative. If I'm putting it in exactly for x, -2 quantity squared plus 4 times x, which is -2, plus 5. And that's going to be my y value of my vertex. In this case, actually, I can just call it k. Well, -2 squared, it's like saying -2 times -2, which is positive 4. 4 times -2 is -8. And then I have my plus 5 here. And when I do this calculation, 4 minus 8 is -4, plus 5 is 1. And I have my y value of my vertex. Now I can just put that into my vertex form. I can just substitute it in for the letters in my vertex form. A is the same as the A for my standard form, so I don't have to write it because it's just 1. So I'm going to have y equals x minus h. Well, h is my x value of my vertex. In this case, it's -2. X minus -2. X minus -2. Right? X minus -2, x plus 2. Quantity squared plus my k value, which is 1, so plus 1. And that's another way to put it into vertex form. Here I have a quadratic equation with an a value that's not 1. And I want to complete the square to put this into vertex form. Remember, vertex form is going to be a times x minus h quantity squared plus k, where h and k are my x and y values of my vertex. Okay, remember what I did first. I have to take just the first 2 terms because I want to make a new trinomial that's a perfect square. So I'm going to leave a space here. But really, instead of jumping right to taking half of my b term like I did before and putting it down into the x plus whatever 8, I'm not going to get the right answer if I do that because I've got this a value that is not 1. I first have to divide that out so that my a value in my perfect square binomial is a 1. Well, since this is an equation of y equals, I'm not going to do anything to the left side at all. I'm only going to change things on the right side. So instead of dividing everything by 2, I'm going to factor it out, but I'd only need to factor it out of these first 2. I don't need to factor it out of the 3. So I take these first 2 terms, the a and b term, and I factor out my 2. I'm going to be left with x squared. 16 divided by 2 is 8. So 8x. And I'm going to leave a space. And I've got my plus 3 over here. Now I can take this trinomial that I don't have a c term for yet and make that a perfect square. Got to bring down my 2. This is going to be x plus something quantity squared. And to know what to put there, remember that is half of my b value. Half of 8 is 4, and it's positive, so positive 4. Now, to know my new c term, remember it's this value quantity squared, this value squared. That value squared, 4 squared is 16. So remember, I can't just go ahead and add a 16 inside here and call it good without doing anything else to the equation. Since this is an equation, I have to keep it balanced. So I have to subtract something. But remember, this isn't just 16. It's actually 16 times 2 because this 2 I factored out. So I have to recognize that that 2 is being multiplied by my perfect square binomial here. Instead of adding 16 to make this a perfect square, I'm really having to add 32 because when I factor out that 2, it's going to be 16. And then I can write it as this. So remember that 2 is being multiplied by that. So in order to keep this balanced, I just added 32. Therefore, I have to subtract 32. And when I do that, I get 3 minus 32. Well, 32 minus 3 is 29. So this is negative 29. 3 minus 32. And now I have it in vertex form, where my vertex is negative 4, because the opposite of what's inside the parentheses, comma, negative 29, where my h and k are, my h is what I'm subtracting from x, my k is what I'm adding on the end here. I'm adding a negative 29, so it's negative 29. I'm subtracting a negative 4 here, so it's negative 4. And there I have that in vertex form. So I just changed that from standard form to vertex form by completing the square. Let's look at the other method I showed. If I had the same equation, let's say y equals 2x squared plus 16x plus 3. Okay, remember my h value is my x value, my vertex, and my vertex is on the axis of symmetry, and the equation for the axis of symmetry is x equals negative b over 2a. Therefore, I can find my h value by taking the same thing, negative b over 2a. Negative b in this case is negative 16, so negative 16. 2a is 2 times 2. I'll write it here, 2 times a, 2 times 2, and negative 16 over 2 times 2. Well, 2 times 2 is 4. 16 divided by 4 is 4, and it's negative in this case. So sure enough, I do have my x value, my vertex, that's negative 4. To get my y value, anytime you have an x value and you want to get the y value and you have the function, you just put that in for x. So my y value can be found by putting negative 4 in for x. Anywhere I see an x, I put a negative 4. So 2 times x squared, negative 4 squared, plus 16 times negative 4, plus 3. Order of operations, I do the exponent first. Negative 4 squared is negative 4 times negative 4, which is 16. And then I multiply that by 2, and I get 32. 16 times negative 4, might not know that off the top of your head, but it is 64. 16 times negative 4 is negative 64. And I have my plus 3. Well, 32 is half of 64. So when I subtract 64 from 32, I get negative 32. And I have my plus 3 still, for a total of negative 29. Sure enough, that is my k value that I found before.